the next part of the geometry basic concepts would be what we call a circle. Hopefully that shape is familiar to everyone. So we know what circles look like. Now we're just going to talk about different pieces of a circle. The formal definition of a circle says it's the set of all points, which we've talked about points before, that are all the same distance from your center point. So the center obviously is smack dab in the middle of the circle, and we always name points with capital letters, so maybe I call that point X or center X. And a circle is created by all these tiny little dots that go all the way around the entire shape. Now, those dots are all the same distance from the X in the middle, okay? And that's what creates that perfectly round shape, so that's very important. Within circles, we have two unique segments that hopefully you've recognized before from previous math classes. But the diameter is a segment that goes straight from one side of the shape through the center to the other side of the shape. So that is a diameter. So we'll say it's a segment. Whoops. Make sure I switch my pen. So a segment from one side to the other, and it has to go through the center. Okay? And that is going to be a measurement. It could be in inches, meters, centimeters. They'll usually give that to you. Okay? So if I wanted to name this particular diameter, I would name it as segment GR. Okay, so segment GR would be our diameter. When we deal with a radius, okay, a radius goes from the center to the edge of the circle. Okay, so that might be from the center X all the way to some point on the edge of the circle. And they can go in any place in the circle. That's where it's kind of unique. So maybe we can call that radius segment XB, or you could name it segment BX. Doesn't matter, same label, just like we practiced when we named segments in the last video. So the unique relationship is a diameter, okay? So the diameter is double the radius. So for example, I could tell you that my radius here is 6 inches. That would mean that the entire diameter would be 12 inches. So all you do is take the radius length and multiply it by 2. And it can work the other way around. I could tell you that the diameter is 30 centimeters. And if I divide by 2, then that means my radius would be 15 centimeters. So they are related to each other. The other thing is you can draw a radius anywhere and the measurements will always be the same. So for example, if I draw a radius in from X to point T, then that means that the radius XT and the radius XB have to be equal. So if we know XB is 6, that also means that XT is 6 inches. So no matter where you draw a radius in, those will be equal. No matter where you draw a diameter in, those will always be equal. Okay, so make sure you understand how to draw those different segments and also how they're related to each other, because that's going to be very helpful. So in this picture, I just want to know, based on what is drawn, which segments are equal to each other. And if you remember from the last slide, we just said diameters always have to be equal to each other, and each radius always has to be equal to each other. So if I look at this picture, I only see one diameter, and that's from F to D. So I don't know any other segments that are equal to FD, so we don't want to use that. However, I do see at least a couple different radius segments. So I see that there's a radius from A to C, okay, because remember, a radius goes from the center to the edge. I also know that I see A to B, so that's another radius. And then there's also a radius from A to D, as well as from A to F. So all 4 of those would have to be the same length because they start at the center and then they go to the edge of the circle. So those would be my 4 segments, and I could go ahead and list them there. Segment AB, and then segment AC, segment AD, and segment AF are all equal. And then we'd be done. So always look for a radius or a diameter, and then you should be good to go. Now, the last two concepts we're going to be referring to in this lesson are about two kinds of lines. The first one is what we call perpendicular lines. These are when you have two lines or two segments that cross and form a 90-degree angle. And remember, when we talk about right angles or 90-degree angles, we use this little box here in the corner. Okay, so you can think of perpendicular lines like two roads that are at an intersection. Okay, so they cross each other, they form right angles, same thing here. So what I could do is say that these two lines are perpendicular, and to write that, I would say line GH is perpendicular. That's the symbol for perpendicular. It's perpendicular to line LK. And then we'd be done. Now, if they asked where the two lines meet or where they intersect, that would be at point M. So just know where they cross. The word intersect means that they cross. And if I asked what the angle measures were, then you could say that every angle here would have to be 90 degrees because they have to form four right angles. Okay. Now, parallel lines are the opposite. Perpendicular lines, they cross and they form a right angle. Parallel lines are lines that never cross. So that might look like this. Here's one line and then another line here drawn in where they do not intersect. Okay, so these would be parallel, and if I named them, here's one line, I'd say that line XY is parallel. So the symbol for parallel is two vertical lines. It's parallel to line RT. And we'd be done. So perpendicular cross and make four right angles. Parallel lines never cross. And that's it for today's lesson. So if you have any questions about how to name things or how we determine if they're parallel or perpendicular, anything like that, make sure you let me know. But hopefully this was helpful to get you started. Thanks.